So we have started our recording. So we will quickly revise our stack ADT and how to code for the stack ADT. Right. So stack ADT is a data type where the insertion and deletion are possible from only one end. Okay, and other end is closed. So you can imagine a stack where one end is open, and from the same end you have to either insert the item or delete the item, like a stack of a plate. So P1, P2, P3, P5. So you can take a plate from this end or insert a plate from this end only. So the major operation will be push and pop. The auxiliary operation will be top to find the top size, isEmpty, isFull. So it follows the LIFO rule, last in, first out. So there are many direct applications of this stack, such as the evaluation of postfix expression, conversion of infix to postfix, infix to prefix, balance the parenthesis to check whether a given expression have the balanced parenthesis or not, to find a tags in HTML or XML, to find a matching tags in HTML or XML, undo sequence in a text editor, page browser history, implementation of function including recursion. There are indirect applications like the graph traversal, depth first search, etc. So there are exceptions in the stack, such as Stack Overflow. When the stack is empty, Stack Overflow, when the stack is full and you are trying to take something out from the stack. So that situation is known as Stack Overflow. Stack is full and you are trying to insert a new element into the stack. So that will be known by top equal to MaxSize -1. So top is a variable that manages the stack. It will contain the address or the index of the topmost element. Second exception in the stack is Stack Underflow. Stack is empty and you are trying to pop from the stack. So at that scenario, top will be equal to -1. So there are no elements. So we can implement the stack using static array, using dynamic array, using the linked list. We'll see today the implementation of stack using static array, but using structure. Okay. So just we'll quickly discuss the pseudocode and then we'll discuss the actual implementation using the stack. So when we are pushing, so suppose S is the stack, top is the variable, MaxSize and the X. So here we have to pass the S array, top, MaxSize, X. So if top equal to MaxSize -1, print overflow return. So this is the exceptions we have to check first. If there is a space, then only we can push. If there is no space, we have to just print overflow and return. Otherwise, increment the top by 1 and put the new element at the S top and return. So this is the pseudocode for the push logic. Similarly, for the pop logic, of course, you have to take S top or pop S top. If top equal to -1, then you don't have any element. So you will just store int mean. So you can define int mean as -999, or you can use the library to define the int mean, and you return print underflow and then return item, because the pop has to return something. So even though the stack is empty, it has to return int mean. Otherwise, if this exception does not happen, then the item equal to S top, decrease the top by -1 and return the item. So this is the pseudocode of the pop. Now, we'll discuss the actual code. But before going to the actual code, why we are using this structure for implementing the stack? Why? So what are the other options? The other option include the global variable. We can have a global variable. What are the global variable? We can define the global variable of the array, the max size, as well as top. What will be the drawback here? Drawback, it is exposed to all of these are exposed to drawback. These are exposed to this variable are exposed to all the functions. Are exposed to all functions, and any function can edit them by mistake also. So this is not a good style of coding. This is not, you have to select the variable when you are importing something for reusability. So for reusability concept also, this global variable concept does not suit very well. Otherwise, you can pass in the function, but you have to pass everything. So suppose the push function, you have to pass the array, you have to pass the max size, you have to pass the top, so many things. So instead of separately passing the so many things, why can't we pack something like inside a box, which have the different compartment, one compartment for array, one compartment for max size, one compartment for top. Okay. And then we can pass this as a box. So we have encapsulated all the relevant items in a box, nicely packed in a box. Like if you want to give multiple sweets to a person, you will not give one by one or separate sweet. You will have a nice box where you will have a separate compartment for each type of the sweet. And then you will nicely give a single box. Similar way, we want to encapsulate the whole variable, all the variable in a stack. So we'll create a user-defined data structure named as stack using the concept called structure in the C. So this is our motivation. And once you have created this nice box, it will be very easy to manage, operate, change, edit, access the individual compartment. So only once you have to visualize or understand the picture, how to make this compartment, how to make a box access the individual compartment. Going to this. So this is how you will define a stack. So here you are defining a stack from this line number 5 to line number 10. I hope this text is visible. So let me enlarge a little bit, try to enlarge if possible. Okay. So this, the struct is the keyword that helps us to define our own data structure. So the name of the data structure that we have given is the stack. Okay, it has the 3 compartments. One is the array base address int star. So here is the A, the name. Here is the data type int star. Another is the max size. Here is the max size. Here is the int data type, and the top and the int. So top will manage the stack. This encapsulated in a single box. And suppose this whole box start at 5,000. So we can just pass the 5,000 to manipulate everything. So if we have we can define the structure variable in 2 ways. So we have alias, given the alias or the nickname using type def, and we have alias using my stack. So we can have either define the, so this is how we define the structure stack or alias my stack. We have not declared any variable of the stack data type. This is just, we have created a box dimension, a box prototype, box design. To have an instance of a box, a real box, we can define a variable of the my stack data type, which will have a stack data type like this, either my stack S1 or my stack star S2. If we define like my stack S1, we have to access the compartment like S1.a, S1.maxSize to access this, S1.top to access this. Wherever, if we define my stack star S2, okay, so this will be a variable pointer type. So now we have to use arrow operator, S2 arrow A to access this, S2 arrow max size to access this, S2 arrow top to access this. And these are the different functions that will define or use over the stack. So this is called function prototype or function declaration. So init stack, that will initialize a stack, create a nice box like this, create an array, of the max size, initialize the top for the initial condition. So whenever stack is empty, top is initialized as -1. So do all those things and return the base address like 5,000. Then we have void push. So it will take two things, stack pointer and int x, the new data to be added. Then the pop my stack star s, and it will return the top element that is deleted. Then the show stack to show the content of the stack. So these are the four functions that we are going to discuss. So any doubt till now, you can let me know. Either you can unmute or you can write message in the chat. Okay, so init part will create, see, we have just defined this template, the box dimension, what will be the compartment in box. But in reality, we have not created a box. So we have to create a box like this. We have to create this compartment, create the array of max size, initialize the top variable, initialize the value of max size. All those things will be done by init stack. So before using the stack or before calling any push or pop function, we have to do the initialization on the stack. So init part will initialize a stack. Is it clear now? Do you want me to repeat? Okay, yeah, good question. So my stack star means the init stack will return a pointer. Star means pointer to the data type of my stack. So suppose this we have created a box like this that starts at 5,000 address. So this init stack will return 5,000. So what is 5,000? 5,000 is address. Address to what? Address to my stack variable. When you go to the my stack, when you go to the 5,000 address, you find the data type of my stack. So that's why my stack star. The return type of the init function is my stack star. Like the return type of the push function is void. The return type of the pop function is int. Likewise, the return type of the init stack function is the my stack star. Let's go ahead. So let us understand the init stack function because that is the core function. Okay. So what the init stack function is just taking max size into max size. So you have declared a variable my stack star s. You will allocate a memory for stack s. How? Using the malloc size of my stack. Okay. So malloc size of my stack. So my stack has 3 compartments. So here you are getting 3 compartments. Okay. So it will find out a space and it will create a nice space for the 3 compartments in which one compartment is array, another is max size, another is top. This is a int star, this is a int, this is a int. So this will nicely create this box by using the malloc size of my stack. And suppose this is created at address 5,000. So this will return. So s variable, the value will be saved as 5,000. So this is the line number 30. Yes, it will return the starting address of the stack. Init stack will return the starting address of the stack data type. And also initialize the different compartment value. So this line number 30 is clear. We are just creating the space for the my stack. So once this is done, there is a possibility that it fails to create. So we have to just handle those cases. So whenever it fails to create this box, it will return null. So if s equal to run, you have to just return. You have to return null and you don't have to do any of the remaining things. Okay. But if s is not null, you will create the array, right? So s dot a. So this is the base address, array base address. So you will create a new array of max size. So size of int into the max size. That much space you will allocate. So likewise, you are creating an array here. Suppose max size is 5. So you are creating a dimension of the 5. So this much space. And let's say the starting address is 100. So this will return 100 and s dot a will be 100. Am I clear in line number 35? So this is creating like this. Now, here also it can fail to create the array. So in that case, s dot array will be null. So we'll free the structure, will return the null. Otherwise, we have to fill up the value s dot max size equal to max size, that is 5, s dot top equal to -1, and return s. So that is the thing. So that's complete the definition of init stack. So we'll wait for 1 minute for your understanding. And if you have any query from line number 26 to 45, please ask. Can you also type in the chat if everything is clear to you so that I can proceed? I request everyone to type in the chat if everything is clear. Or if you have any doubt. No, not for each compartment variable, we have to use the malloc. We have created a malloc for the stack. See, okay. Thanks for asking this. See, the s is a variable which contains the address to the stack. So s contains the 5,000. But initially it will not contain 5,000. So s will be like a question mark. So somewhere you have to create a stack compartment like this. So to create this, you will call a malloc. And suppose this is created as 10,000, 10K. So it will return 10K and it will be assigned as 10K. So to create this, we are using the malloc. Second, the first compartment, the array. Array will contain the base address, like actual array is here. So to create this, we are calling the malloc to create this array. So this array base address is stored here. 100 is single address, but at the 100th address, there are the space to store the 5 integer. So to store the 5 integer, to allocate the space to store 5 integer, we have to use the malloc. So we have used the malloc here. We have used the malloc here. Not for the creating max size, not for the creating top. We have just assigned the s arrow max size equal to max size, that is 5. We have just assigned X arrow top equal to -1. We have not used the malloc here. In the line 41 and 42, we have not used the malloc to assign the max size in the top. Now everybody is clear. Can you please take some effort to write in the chat if everybody is clear? Okay, thank you. We'll proceed. So push. So this is the simple push function. So what we have to do, so since we have encapsulated everything in the S variable, we don't have to pass the max size top separately. Everything will be contained in S. S is 5000, S arrow A, S arrow max size, S arrow top. So we have just increasing the top by 1. Suppose 1620. So push S1 16. So it will in top is -1, top will be increased by 0, and 0 will store 16. Then push S1 20. Then top will be increased by 1. So top value will be 1. Currently top value will be 1. Okay. And we will keep at 1 index 20 likewise. But here we are not taking the exception. Actual push code should take the exceptions. So how to check the exception? Can you write in the chat what can be exception when we are trying to push an element into the stack? What kind of exception we can have? What kind of exception? What are the type of exception that we discussed just now that can happen in the stack? What was the type of exception? Okay, one was the underflow. What was the other flow? Stack underflow. One was the stack underflow. So there was two exception. One was stack underflow. Other was stack overflow, right? So while pushing, what exception can occur? Stack overflow or stack underflow? Yes, correct. So while pushing, we can have a stack overflow. So before doing this, we have to check for overflow. But to simplify the things, we have done just this. Similarly, in the pop, what we have to do, int x, that will be assigned, x will be assigned as deleted element. So x will be s array. Array instead of array, it has to be a. If we follow this notation, s arrow a and s arrow top. So this will be the element that we are going to be deleted, that we stored in the x, and just decrement the top by -1 and return x. So this is the very simple case when we are assuming that we are living in a nice world where there are no stack overflow, no underflow. Actually, in the actual scenario, in the real scenario, we have to check for the underflow here. And here we have to check for the overflow. So this is the summarized code. Then we will see the code with the compilers in the actions, like no. We'll see how it runs line by line. So just give me 1 minute. I will set up. Till the time, if you have any doubt here, please let me know. So I will project my computer and then you can see a stack code, simple stack code. Okay. So here we have defined a structure of a stack. We have defined the functions push, pop, get top, delete stack, check stack, overflow, check underflow. So this is function prototype. We have just declared the functions. So this is a good style of coding where before actually telling how to do the functions, how to implement the function, you declare the function prototype or function declaration. Then we have a main function. So if you have defined using this structure and this way, you can simultaneously operate on the multiple stack. You can code even for the application of the stack, like the balanced parenthesis or anything without any hassle. So we are using the push S1, push S14, push S11, push S119, so stack S1, X equal to pop S1, and this is the simple code. Then this is the init stack, the same code that we have discussed. Push, we have just added the check stack overflow condition. Else part is the same. So stack, it will just print all the element of the stack. The pop stack, we have added the stack underflow condition. So we are copying the code from here and we are pasting in the browser, okay, in the Python tutor code visualizer. So you can see that all the code is pasted here. So we want to visualize the execution line by line. So here it started with the int main, and okay, so the S1 X. Okay, so then the red line will move and it will execute one line by line, and it will show the memory details here. So the memory address. Let me show the memory address. So this. So S1 is question mark, no value. X is question mark. So next, so S1 is calling init stack 10. So now it will go to the init stack function. So it will go into the init stack function. Okay, so init stack. So max size S. There are two variables inside that. So max size is 10. We have passed the 10. Then S, nothing is allocated here. It is still question mark. Now it will execute S equal to malloc size of my stack. So when after this green is executed, red means next line to be executed. So when the line number 57 is executed, you can see that it created this block. This block has three compartments. First is the array, name is the array. Second is the max size. Third is the top. This is a pointer to integer, int star. This is a integer. This is a integer. All three value is the question mark, garbage value. And this, the address that is created is 0x5402040. And that value is assigned to the S here. So you can see by the reference also. So this malloc is clear, right? How the line number 57 behaves. Just I will wait and let me know if you have any doubt. Is line number 57 clear to everyone? Is the visualization of line number 57 clear to everyone? Is this screen visible nicely? Can you read through the screen? So can I proceed next? Can you please respond in the message? Okay. So next we'll go to the next line number. If S is equal to null, but in this case, as is not null, we have successfully created the stack variable S, and that's why it is not null. So we came to the line number 61. So this 58 has executed, but this is false. So next line will be executed, it will be 61. So S arrow array. Next, when we execute line number 61, malloc size of int into max size. So now we had the max size equal to 10. So it has created an array of 10 integer starting from 0x5402090 to 0x54020B4. So it has assigned this value in the array. This was the line number 61. So this is the only two places where we are using the malloc. One is the line number 57 to create this structure, line number 61 to create this array. Once this is done, we'll again cross check if the array is created successfully or not. If it is not, S or dot arrow array will be null. So this array is not null, so it will come to 68. So now you can see the still max size is question mark, top is question mark. Now it is time to assign the correct value to the max size and the top. Okay, so what is the max size here? So we have passed 10. So max size will be assigned to 10. So after executing the line number 68, you can see there is an update here in the max size. Max size is updated as 10. Next, when we execute the line number 69, top will be updated. Top is updated as -1. Now we are going to return this to the calling function, return this address 0x5402040, and that will be saved in the S. So this is done, and this here it will be saved in S1. Now we are calling push S14, right? So now you can see that each of this array value is the question mark. The top is -1. It indicates the array is empty. When we call push S14, what will happen? It will go to the push code. It will check for the stack overflow. Basically, if the top equal to max size -1. Okay. So that is false. So that is equal to here, take stack overflow. If s dot max size -1 equal to s dot top, that is false. So it will return here false, and it will come here as arrow top. It will increment by +1. So it has executed 76, and next line it will execute 80. When it executes the line number 80, the s top becomes 0. Now it has to update the 0th index of the array. S arrow array means this starting address. The S arrow top means 0. This will be X, whatever the X is passed. Okay, so this is updated at 4. So in this way, we have pushed the first element as 4 in the S. Likewise, we can push the 1, the second element. We have incremented the top, and we have pulled the 1 in the second element. Next, we want to pull the third element, 19. So we have incremented the top again. Top becomes 2, and third element becomes 19. So then we want to show stack. So stack will come here. It will just print all the value. So stack element are 4. So you can see here stack element are 4, 1, 19. Then x equal to pop s. It will come pop. It will check for stack underflow. If s arrow top equal to -1, it is not -1. It will return false. It will come here. It will store the topmost element. So top equal to 2. So topmost element is 19 at the index 2. So it will store that in x equal to 19. And then it will decrement the top by 1. So top become 1. So even though 19 is there, so this will consider that we have that only 2 valid elements, 4 and 1. And then it will return this 19 here to the x to the 9. And then we can print the deleted element is 19 here. And then when you show the stack, okay, so when you call the show the stack, it will be coming here, the stack element, it will print 4, 1. It will not print 19, though the 19 is there, because the top is 1, 1. So the stack element are 4, 1. So I hope this demonstration of the stack is clear, and it helps you to understand how to implement the stack using the structure, why the structure is needed, or you can naturally code using the structure. In terms of the queue, only in this place of the top, there would be 2 compartments, front and the rear. Remaining things will be the same. In the next class, we'll discuss about the queue. So if you have any doubt now, please ask. If you want to discuss any specific function, any specific visualization, anything, please let me know. Is it clear to everyone? Okay, thank you everyone. So we'll stop here. So please practice the stack code and let me know if you are facing any difficulty. The next day we'll discuss about the queue code, followed by the linked list